All right, today we're going to completely flip the script on something we all think we understand: how to fly an airplane. We're going to toss out the old rules of thumb and look at flight for what it really is: pure energy management. So let's just dive right into the big question.
So, if I asked you what controls a plane's altitude, you'd probably say, easy, you pull back on the yoke. And for speed, the throttle, of course. I mean, it seems completely obvious. But what if I told you that simple way of thinking isn't just a little bit wrong, it's dangerously wrong? And look, this isn't just some academic debate. The FAA itself points out that getting this energy management concept wrong is a major factor in the three most common types of fatal plane crashes. So this isn't trivia night, folks. This is a core safety concept.
To really get this, we have to stop seeing a plane as just a machine with wings and start thinking of it as an energy system. Seriously, a plane in the air is basically a flying bank account, and it has two different kinds of funds.
The first account is its potential energy, and really, that's just a fancy way of saying altitude. The higher the plane is, the more potential energy it has stored up. Just think of this as the money you have saved away. It's your height in the bank.
The second account is its kinetic energy. This is the energy of motion, which for an airplane means its airspeed. The faster you're going, the more kinetic energy you've got. This is like your checking account. It's the speed you have ready to spend right now.
But here's the absolute key to all of this. These two accounts are linked. A pilot can, at any time, trade one for the other. They can cash in altitude to get more airspeed, or they can spend their airspeed to buy more altitude. It's just like transferring money between your savings and checking. They're totally interchangeable.
So if altitude and airspeed are really just two different pockets for the same energy, what do the controls actually do? Well, this is where we need a completely new mental model for what it means to fly a plane.
Okay, this is the big idea right here. The throttle, it doesn't just control speed. It's the total energy controller. It's the one that determines how much energy is getting deposited into the whole system from the engine or withdrawn by drag. Now the elevator, that's the energy distribution controller. It doesn't create any new energy. It just decides how to spend what you've got. Do we put it in the altitude account or the airspeed account?
You know, a really great way to picture this comes from the FAA's own handbook. Think of it like a plumbing system. The throttle is the main spigot, controlling how much water or energy is flowing into the system. And that system has two big connected tanks, one for altitude and one for airspeed. The elevator, that's just the valve between the two tanks. It decides if the energy fills up the altitude tank, the airspeed tank, or lets one drain into the other.
Now, pilots don't just have to feel this out, they can actually see it. They use a kind of chart called an energy map to visualize their energy state and figure out their next move. Let's check it out. So just like a regular map uses latitude and longitude to tell you where you are, an energy map uses altitude and airspeed to define the plane's energy position. Every single point on this map is a specific combo of height and speed. And the rules for moving around on this map are actually really simple. If you want to get to a state with more total energy, say climbing while holding your speed steady, you have to add more energy to the system. The only way to do that is with the throttle. But if you just want to trade speed for height, staying on the same total energy line, well, that's just a simple exchange. That's a job for the elevator. This map makes it perfectly clear what each control is really for.
Okay, so this is all pretty cool theory, but why does it matter so much? Because in a bad situation, having this mental model isn't just helpful, it can be the difference between a safe recovery and a disaster.
So let's imagine a classic scenario. A pilot is on final approach to land, but realizes, uh-oh, they're too low. The gut instinct for a lot of people is to just yank back on the yoke to get the nose up. But is that actually the right thing to do? Well, the answer depends entirely on the plane's energy state. If you're low and slow, you have a total energy deficit. Your bank account is low, you need to add energy, so you hit the throttle first. But what if you're low and fast? That's a distribution error. You have plenty of energy, it's just in the wrong account. In that case, you use the elevator to trade that extra speed for the altitude you need. You have to diagnose the energy problem before you can fix it.
All right, now for a much more terrifying situation. Imagine a plane taking off in the mountains. The ground is rising ahead of you, and it's rising faster than you are. The pilot keeps pulling the nose up trying to climb, but it's not working. The plane stops climbing, and now the airspeed is dropping fast. The stall horn is about to start screaming. What do you do?
Every single survival instinct is screaming at you to pull up, to fight for every last inch of altitude. But the only way to survive this is to do the absolute opposite of what feels right. You have to point the nose down. I know it sounds completely insane, but let's break down why it's the only move that works.
See, the pilot is stuck on what's called the backside of the power curve. That's a nasty place where the nose is so high that pulling back actually increases drag and just makes everything worse, bleeding off whatever energy is left. The engine just can't keep up. So by pushing the nose down, the pilot makes a deliberate trade. They spend a little bit from their altitude account to make a huge deposit into their airspeed account. That sudden rush of speed slashes the drag, which means the engine suddenly has excess power again. And with that new surplus of energy, the plane can finally start a real, sustainable climb and get over that obstacle. It's a life-saving energy transaction.
So in the end, it really all boils down to this one powerful idea from the FAA. Flying isn't just about pushing and pulling controls, it is about managing a dynamic energy state. From the moment you take off to the moment you land, a pilot's #1 job is to be a good energy manager, making smart deposits, withdrawals, and transfers to keep the flight safe. And once you understand that, well, it changes everything.